is taken as an input to the AM demodulator. Now, what is the purpose of AM demodulator here? Yes. What is the function of AM demodulator? What is our purpose for using the AM demodulator? Yes.
मैम
Yes.
मैम डीमॉड्यूलेटर का फंक्शन
Demodulated the original signal or
Function.
extract the original message signal from the amplitude modulated wave. Now see here, assume the band pass noise is mixed with amplitude modulated wave. We have two tabs here. Your amplitude modulated wave that is added or mixed with noise signal in this diagram. So this combination, this addition is applied at the input of the AM demodulator. That means what is V of t? That is equal to S of t, that is your amplitude modulated wave, plus N of t, that is your noise signal. And this input V of t is given to the AM demodulator. Is that clear? Yes.
Yes, ma'am.
Okay. Please note down this equation. V of t is equal to S of t plus N of t. S of t is already defined. That is standard equation of AM wave. We have already written this relation on your notebook. That is S of t is equal to AC1 plus KA M of t cos 2 pi FCT. Please wait. Have you noted this V of t is equal to S of t plus N of t? Yes.
Yes, ma'am.
Okay. Now what is S of t? That is your standard equation of amplitude modulated wave. That is AC 1 plus KA M of t into cos 2 pi FCT. Now what is noise signal? Noise signal, please note this equation. N of t is equal to, there are two types of components in noisy signal. One is NIT, that is in phase component of noise, and I T cos 2 pi FCT. Please note down this equation first. FCT minus NQT, that is quadrature component of noise. So there are two components in a noisy signal N of t. One is in phase component and second is quadrature component. NIT cos 2 pi FCT minus NQT sine 2 pi FCT. Now we have to find out the value of V of t. We already know the value of S of t. Now N of t is already defined in this equation. Put all these two values and find out the value of Vt. This one. After this, you have to rearrange the terms. एक साइड आप cos 2 pi FCT बना लो, एक आप sin 2 pi FCT बना लो. Do it fast and tell me इतना आ गया कि नहीं. Suppose this is equation number 2. Achieve it. Yes, done. हाँ जी, करती put value. Yes, Arun.
मैम कर रहा हूँ.
Okay. It's NIT, not one, it's NIT. This is Q, ENIT. NIT is in phase component of noise, and this is quadrature phase component of noise. Done? Up to equation number 2.
Yes, ma'am.
Okay. Now, what is the output of AM demodulator? D of T. Now D of T क्या है? That is output of demodulator, just the envelope of the amplitude modulated signal. Amplitude modulated signal है S of T. Then V of T is an input that is applied to the AM demodulator. So we have to just extract the message signal from this equation. तो इसमें देखो two types of components are there. One is cos के साथ आ रही है term, this one, and second is sin. And you already know how to take the mod or magnitude of this equation. पता है सभी को? Yes, friends. Say yes or no.
मैम एक बार बता दीजिए.
Suppose we have term A plus eta B. How to take the magnitude of this? That is real square A square plus imaginary का square. Yes.
Yes, ma'am.
Now here it's here cos. अगर ऐसे हो यहाँ पे हो cos A हो sin B, तो उसका भी कैसे लोगे? Cos A का स्क्वायर प्लस sin B का होल स्क्वायर. क्लियर है? सिमिलरली यहाँ पे देखो इट्स cos 2 pi fct, that is sin 2 pi fct, और इसके साथ टर्म है ये वाली, और इसके साथ है n क्यूटी. नेगेटिव, नेगेटिव का स्क्वायर करोगे पॉजिटिव बन जाएगा. यू विल गेट दिस. यस और नो?
Yes, ma'am.
cos रियल के साथ आता है, sin आपका इमेजिनरी टर्म के साथ आता है. दैट्स व्हाई इट्स अ इन फेज कंपोनेंट एंड दिस वन इज क्वाड्रेचर कंपोनेंट. And this NQT, that is quadrature component of noise, is approximately equal to 0. अब इसे 0 किया, इतनी टर्म रहेगी, इस टर्म का होल स्क्वायर, you will get this answer. So D of T is approximately equal to AC plus AC KAM of T plus NIT. Is that clear?
Yes, ma'am.
Now tell me, out of this, which one is your required signal? Our purpose of AM demodulator is to extract the message signal. अब इसमें message signal कौन सा है? Tell me.
मैम जिसमें M of T आ रहा है.
जिसमें M of T आ रहा है. Only one, the second term. That means these two are not required. Our main target is AC KAM of T. That is your output of AM demodulator. AC KAM of T. क्यों? क्योंकि इसमें मैसेज सिग्नल आ रहा है. And how to find out the average power of this demodulated signal? पहले आप यहाँ पे लिख लो D of T is equal to AC KAM of T. And how to find out the average power? We already know Vm by root 2 by the whole square. अब यहाँ पे amplitude क्या है? That is AC KAM of T. This form by root 2 का square कर दिया. And what is M square T? कल भी हमने पढ़ा था. That is equal to P, power of the message signal. वो P के equal आ गया. Done?
Yes, ma'am.
And what is the noise average power at the output? PNO, that is equal to W into N0. W is your message bandwidth and N0 is your output noise signal. Now, if any doubt in this slide, then ask me. Have you noted all the equations?
मैम W और N नॉट क्या था?
W is your message bandwidth and not as output noise signal.
Okay,
Done?
ma'am. Yes, ma'am.
Now any question? No?
No, ma'am.
Okay. Now after this, substitute the values to find out the signal to noise ratio for output. How to find out? First put the average power of demodulated signal. And जो हमने निकाली है that is AC square. Wait. AC square. हाँ जी कितनी निकाली है? KA square, that is amplitude sensitivity, into P power of the message signal, that is equal to MC square by 2. इतनी थी? Yes.
Yes, ma'am.
Okay. And second, divide by average power of noise and output, और वो कितनी है? That is W into N naught. Now put all the values in this equation and find out the signal to noise ratio for output. Do it fast. Done? Yes, rest all students, any doubt?
No, ma'am.
Have you solved? ये इतना अचीव कर लिया सभी ने?
Yes, ma'am.
Okay. Now after this, we have to find out the figure of merit of AM receiver. And what is the formula of figure of merit of AM receiver? That is ratio of signal to noise ratio of output by signal to noise ratio of channel. And we have already calculated channel की signal to noise ratio भी हमने calculate करी है. Wait. This one कल करी थी AC square 1 plus KA square P by 2W N naught, और हमने आउटपुट की भी नॉइस रेशियो निकाली है सिग्नल टू नॉइस. Put both the values in this and find out the value of figure of merit. Yes, done. Just you have to put the values and cancel out the terms जो cancel हो रही हैं and achieve the answer. AC square cancel हो जाएगा. Yes.
मैम P K A स्क्वायर के साथ मल्टीप्लाई में है ना?
कितना आ रहा है देखो, ये ब्रैकेट है. ओके, ये P इसके साथ है ऐसे.
Yes, ma'am.
Okay, wait, I'm writing here. It's P like this. अब ठीक है?
Yes, ma'am.
अब आंसर आ गया इतना?
Yes, ma'am.
Yes. बाकी सभी ने निकाल लिया?
Yes, ma'am.
Okay, सोनिया, राजन,
Yes, ma'am.
okay, कृष्णा and मिथिलेश.
Yes, ma'am.
That is signal to noise ratio for amplitude wave AM. Any question on this, then you can ask me. First हमने क्या किया? We have to calculate signal to noise ratio of a channel. पहले चैनल की निकाली, फिर आउटपुट की सिग्नल टू नॉइस रेशियो निकाली। चैनल की कितनी थी, जस्ट इतनी। जब हम आउटपुट की निकालेंगे ये पूरी निकालेंगे, that is the difference. Now next is signal to noise ratio calculations and double sideband suppressed carrier system. Yes, first tell me the description of this. Hanji, any one of you? It's a double sideband suppressed carrier system in which both the bands are allowed, that is upper and lower for transmission, but carrier is suppressed here. Can you tell me the description? Yes,
Yes, ma'am.
madam. Hanji.
मैम एस ऑफ टी जो सिग्नल है वो ऐड होगा नॉइस सिग्नल के साथ
एम्पलीट्यूड मॉड्यूलेटेड वेव है, डीएसबीएससी इज योर एम्पलीट्यूड मॉड्यूलेटेड वेव ही होती है, बट कैरियर सप्रेस्ड उसमें होगा। एस ऑफ टी दिया आपने डबल साइडबैंड सप्रेस्ड कैरियर सिग्नल एंड दैट मिक्स्ड विद नॉइस सिग्नल। और बैंड पास फिल्टर को दिया, बैंड पास फिल्टर क्या करेगा, जो आपको रिक्वायर्ड है वो पास कर देगा, दैट इज योर आउटपुट V1T, एक रिक्वायर्ड बैंड को पास करेगा, रिजेक्ट ऑल। Second is local oscillator that generates the carrier signal. And what is the value of the carrier signal here? That is C of t is equal to cos 2 pi fct. You can draw it on your notebook. And then product modulator is used, and two inputs are given to the product modulator. One is V1T and second one is C of t is equal to cos 2 pi fct. And from here your output is generated, that is V2T, that is equal to V1T into C of t, or you can also write V1T cos 2 pi fct. And at the last, low pass filter is used to restrict the demodulated output D of t. Now any question? Yes, friends.
नो मैम।
Have you drawn? हाँ जी, अपनी कॉपी पे आपने ड्रॉ कर लिया?
यस मैम।
Now how to calculate signal to noise ratio? First is your double sideband suppressed carrier modulated wave, जो मैंने आपको पहले ही बोली थी कि ये यहाँ पे आ रही है. And what is that is the product of message signal and your carrier signal. So S of t is equal to AC m of t cos 2 pi fct. AC cos 2 pi fct is your carrier, m of t is your message signal. Now we have to find out the average power of this modulated wave, and what's the amplitude here, that is AC m of t. And how to find out the average power, that is AC m of t by √2 और उसका होल स्क्वायर, और m स्क्वायर t की वैल्यू क्या होगी, that is p, already defined, that is power in the message signal. Done. Please solve it on your notebook. Have you derived this?
यस मैम।
After this, average power of noise in the message bandwidth. तो अब noise कितनी होगी चैनल में, message bandwidth में, PNC is equal to W into N naught. W is message bandwidth and N naught is your output noise signal. And after this, we have to calculate the channel signal to noise ratio. And how to calculate? Average power of demodulated, sorry, double sideband suppressed carrier modulated by noise signal. Divide both, you will get this. Try it. Please revert once done. Yes, done. Please do it fast. हाँ जी अरुण आ गया आंसर.
मैम कर रहा हूँ अभी.
सोनिया.
Yes, ma'am, done.
राजन.
डन मैम.
ओके. अब हमने चैनल की सिग्नल टू नॉइस रेशियो निकाली, अब आउटपुट की निकालेंगे. देन डिवाइड बोथ, you will get your figure of merit for double sideband suppressed carrier. Now how to find out the signal to noise ratio of output? पहले हम V1T निकालेंगे, फिर V2T, वहां से D of T निकालेंगे, then average power निकालेंगे. Now very first is V1T. What is V1T? V1T is equal to S of T, that is your double sideband suppressed carrier modulated wave, plus N of T. Write down on your notebook. See, V1T is equal to S of T plus N of T. Standard equation of your double sideband suppressed carrier, and second one is your noise signal. And we already know noise signal is in phase component and quadrature component. Put all the values here, then rearrange the terms, you will get this. Do it fast. Yes, done, students.
Yes मैम.
आपका AC M of T cos 2 pi FT CT है, ये आपकी डबल साइड पर सप्रेस कैरियर है. दिस वन इज योर नॉइस सिग्नल. अब रीअरेंज की टर्म्स कॉस वाली अलग हो गई और आपके साइन वाली अलग हो गई. And what is the value of C of T? That is cos 2 pi FCT, that is generated from local oscillator. You can see here कि आपकी लोकल ऑसिलेटर से कौन सा सिग्नल जनरेट हो रहा है. C of T is equal to cos 2 pi FCT. Then we have to generate the value of V2T. V2T is equal to V1T into C of T. That is the output of product modulator. Product modulator को एक input जा रही है V1T, second जा रही है C of T. Now put the value of V1T and C of T here and solve it. इतना solve करो, then I will tell you आगे क्या करना. Do it first. Yes. Done, students? Arun,
Yes, ma'am. Done.
now see here, cos is multiplied this cos, ये पूरी होल टर्म है यहाँ पे, cos 2 pi fct के साथ मल्टीप्लाई करोगे, यहाँ पे cos के 2 pi fct आ जाएगा, यहाँ पे sin and cos, and you know the formula of cos square theta? Yes. What is the formula of cos square theta? That is equal to? Yes, Arun.
Ma'am, 1 plus cos 2 theta divided by 2.
By 2. And what is the formula of 2 sin A sin B? Or 2 sin theta cos theta? I am writing here. इसका क्या formula होता है? That is equal to sin
Sin 2 theta.
2 theta. अब आपके यहाँ पे क्या है? इसमें 2 नहीं है, तो 2 यहाँ पे डिवाइड हो जाएगा. Yes, I am right.
Yes, ma'am.
Means आपका कैसे है टर्म? I am writing here. ऐसे बने. Now use these two trigonometric identities here. यहाँ पे थीटा की जगह पे 2 pi fct है, वो ये बन जाएगा. यहाँ पे है sin A sin B, वो ये बन जाएगा. Okay. Yes, friends.
Yes, ma'am. Done.
Done.
Yes, ma'am.
Now your d of t is equal to this. How? See here. First solve this equation. इसको ओपन करो इक्वेशन को, ये बन जाएगा AC m of t plus NIT as your in phase component of noise by 2. सेकेंड टर्म को फिर से इसको cos 4 pi fct by 2 के साथ मल्टीप्लाई करोगे, that is AC m of t plus NIT cos 4 pi fct cos 4 pi fct by 2. अब इसमें देखो, अगर इसमें देखें, that is your 4 pi fct into AC, that is not required message signal. Message signal किसमें आपका आ रहा है? This one. बाकी सारी टर्म आपकी रिजेक्ट हो जाएगी. So d of t is equal to, that is the output of demodulator is only this. Are you getting? Yes. Clear है इतना?
Yes, ma'am.
How to achieve? Okay. अब इसमें भी देखो, that is a mixture of signal plus noise. AC MCT as your amplitude of message signal, तो उसकी पावर निकल जाएगी आपकी इतनी. That is equal to, I am writing here AC m of t by 2, and second is in phase component of your noise by 2. You will get this. Verify it कि आ रहा है इतना कि नहीं पावर. Yes. Yes, Arun.
यस मैम आ रहा है.
And second is noise power at the output. Last case में noise power कितनी थी? That is W in I naught. See here. In this case, it's W in N naught. क्यों? यहाँ पे NIT component आपका जो था वो था NIT only. That is in phase component. But here it's NIT by 2 in phase component. So in this case, noise, average power of noise at the output is Pn naught is equal to Wn naught by 4. W is message bandwidth, then noise output signal by 4. Now we have calculated average power of the demodulated signal and noise signal. Divide both, you will get your signal to noise ratio for output. And at the last, divide the signal to noise ratio of output and signal to noise ratio of channel. You will get figure of merit. Put all the values and tell me, is it same or not?
मैम W N नॉट डिवाइड बाय 4 कैसे आया?
और कैसे है? See here, that is equal to AC M of T by 2 and second is in phase component NIT by 2. Same quadrature component भी क्या होएगा? Sorry, it's क्या हाफ होगा. फर्स्ट केस में जो हमने फर्स्ट AM का केस पढ़ा उसमें NI फेस कंपोनेंट था NIT, तो उसमें सिर्फ थी पावर हमारी नॉइस WN नॉट. क्लियर है?
यस मैम.
Put all the values and achieve it. Done? Yes, friends.
Yes मैम डन.
This is all about the signal to noise ratio of double sideband suppressed carrier. Next lecture we will discuss signal to noise ratio and single sideband suppressed carrier.